Okay, so we are here for discussing CodeForces round 954 div 3 solutions. This is the A problem. We are given three integer coordinates x1, x2, and x3 on the x-axis, all between 1 and 10. And I have to find an integer coordinate A on the x-axis such that um, the total distance from the given point to the point A is smallest, is minimal, and it can be x1, x2, and x3 as well. So essentially, what do we have here is it's a pretty simple, straightforward question. We have here is there is a straight line, and on top of that straight line, we have 3 points: x1, x2, and x3. And we have to find a point A, or let's say there is another point A, such that there is the absolute distance from all 3 points, which is A minus x1 plus A minus x2 plus A minus x3. We have to find the A for which this is minimal. Now, intuitively, there are two cases. If A is not equals to x1, x2, or x3, then what happens? What happens basically is I have three positive terms in this expression, and if A is either equals to x1 or equals to x2 or equals to x3, then basically any one of this term becomes equals to 0. One of them. What this visually means is if A was here, let's say, I'm calculating this distance, and this distance, adding them up. If let's say A was here, then I'm adding this distance, and this distance. But let's say I keep A at x1 itself, then I'm basically reducing a distance. I don't need to take the distance between A to x1. This is basically 0. I just need x1 minus x2 and x2 minus x3. So um, that's pretty much the solution. Essentially, there is nothing more there. And this is the code for it. This is the code for it, where I've just taken the three inputs and the three cases, where the x1 is A, x2 is A, and x3 is A. The first, second, the first and the second term, the first and the third term, and the first and the second term for the corresponding cases. And that's it. Okay, so moving on to the second question, we have a matrix of size n cross m where the numbers are where the rows are numbered, sorry, where the rows are numbered from 1 to n from top to bottom, and the columns are numbered 1 to m from left to right, top to bottom, left to right. Now I have to stabilize this matrix using this given algorithm, where there is a definition given of two neighbors. Let's just clear this thing out real quick. I have the first um, example that was given. The first example was 1 2 3 1. Okay, 1 2 3 1. The rows are numbered as 1 2, increasing from 1 to n, top to bottom, and j was numbered 1 2 till m from left to right. And actual um, this is my actual matrix that I have. Right, now it defined neighbors, right? It defined neighbors as uh, whose sum of difference of x coordinates plus difference of y coordinates equal to 1. So if I have cell 0 0 0 1 1 0 1 1 as I comma j, then these two are neighbors and these two are neighbors. Essentially, in a pretty basic sense, I have a cell here, and the cell on the top, the cell to the right, the cell to the left, and the cell to the bottom. These are the neighbors. because these are the neighbors to which this cell will have a difference in any one of the coordinates. If this is x, this is y. If this is I, this is j. This will be I plus 1 comma j. This will be, sorry, not I plus 1 comma j. This will be I comma j plus 1, and this will be I comma j minus 1. This will be I minus 1 comma j, and this will be I plus 1 comma j, right? And essentially, if you look at the difference of coordinates, I minus 1 plus j minus j, this is 1. Similarly, I minus I plus j minus j plus 1, this is 1. Plus I minus I plus j minus 1, this is 1. And I minus I plus 1 plus j minus j, this is 1. So these are all the neighbors that are possible. Now what do I have to do with these neighbors? I have to find a cell I comma j such that its value is strictly greater than all of its neighbors, right? If there is no such cell, then terminate the algorithm. If there are multiple such cells, choose the value with smallest I, and if there are multiple cells, choose the one with smallest j. What does this mean? This means a cell, let's say this value is a, x, y, z, and w. Then if a is greater than x, y, z, and w, all of them, then it satisfies this criteria. And another criteria, if I have multiple such cells in this matrix, right, where I equal to 1, I equal to 2, I equal to 3, then I'll choose the one with minimal I in it, minimal row. And if I have multiple in a row, then I'll choose the one with minimal j, right? If it satisfies this criteria, and if it satisfies this criteria, which is greater than all of it, then I'll replace a by a minus 1. This is what it says. Then replace a by a minus 1 and go to step 1 again. Now, do you agree that, let's say, if I apply this once on this, there are two cells here. The neighbors of 2 are 1 and 1. The neighbors of 3 are 1 and 1. But again, the one with smaller I is 2, so we'll apply this algorithm on 2, and 2 will become 1, and 3 will remain 3. In the next step, I'll apply it on 3 because 3 is the only cell which is greater than all of its neighbors, which are basically 1 and 1. So it becomes 1, 1, 2 and 1, and it finally becomes 1, 1, 1 and 1. Now you can see there are two iterations here. Two iterations, right? I can say with this example that if my cell satisfies these two criteria, having minimum I and minimum j, with it being greater than this, if let's say a minus 1 was also greater than all of its neighbors, that is x, y, z, and w, then I'll still choose this cell only, this cell only. This I and j will be chosen again because it was minimal I and minimal j. There is nothing with an I lesser than its I, its row. There is no column lesser than its column. So can I say there are two things to be said. First, if A is greater than all neighbors, this implies A is greater than, not even equal to, strictly greater than, because it's given in the question, strictly greater. It has to be strictly greater than the maximum of all neighbors, in this case x, y, z, and w. And I can for sure say that this algorithm will remain on this cell only till the time A becomes equal to the maximum of this, the maximum of all neighbors. When it becomes equal to the maximum of all neighbors, for 3 the neighbors were 1 and 1. When it became equal to the maximum of all neighbors, not necessarily equal to all, but equal to maximum of all, let's say it would have been 1, 1, to 3. In this case, 3 is the minimal cell in which I can apply this, and I do this once, I get 1 1 2 2. It is greater than, equal to, now equal to the maximum of its neighbors. The neighbors of 3 were 2 and 1, the maximum of which was 2, so it was greater than both of its neighbors, and now it became equal to its neighbors, which is equal to the maximum of its neighbors, and hence I no longer need to apply this because this is not eligible. This is not greater than all of its neighbors, because for being greater than all of its neighbor, it had to be greater than the maximum of its neighbors. So what does this question come down to? This question simply comes down to the fact that I'm traversing the matrix left to right, each row from top to bottom, to satisfy the minimum I criteria and minimum J criteria. And what I'm essentially doing is I'm checking that if value Aij, if I had to write this pseudo code, then for I from 1 to n, for j from 1 to m, if Aij is greater than max of, strictly greater than, mind you, max of all neighbors, then assign Aij to be equals to max of all neighbors. That's it. Now we'll look at the code for this ones. How do we implement and find the maximum of all neighbors? Yeah. Now we'll look at how do we basically implement this, and what do we do here is we do this. So I take the inputs in and m. Oh, just a second. Is it recording? Yes, it's recording. I take the inputs n and m. I take the grid. This is the grid. Vector int of size n cross m. I take the input. Now I traverse the grid in the same way as I mentioned, from top to bottom, and each row being traversed from left to right. And I take the current val and I do this to find the maximum of all neighbors. What exactly is this? These are basically what I'm saying, that I have a current x coordinate. I want to change it x coordinate. I want to say that I plus dx of k, when you are changing x by this, change y by this, because it's dxk and dyk, so it's x plus 1 and y plus 0, right? Since my neighbors were nothing but, for I comma j, I had I comma j plus 1. This will be I comma j minus 1. This will be I minus 1 comma j, and this will be I plus 1 comma j. That is exactly what I've implemented here. That the new x will be current I plus dx of k, current j plus dy of k. Now if k is 0, this is 1 comma 0, that means the neighboring cell becomes I plus 1 comma j, otherwise it becomes I minus 1 comma j, or it becomes I comma j plus 1, or I comma j minus 1, right? If it is valid, essentially if it is within bounds of the grid, less than n, less than m, greater than equal to 0, then I take the maximum value of its as compared to the maximum that I initialize. This is a arbitrary value maxi, and I take its maximum. If current is maximum, I assign this maximum and I print the final formed grid. That's it. In short, traversal, if it is greater, that means if it is greater than maximum of all neighbors, that means it was greater than all neighbors. Of course, greater than all neighbors is the same as greater than maximum of all neighbors. If that's the case, then assign this. Why? Because This is the one with minimal I and minimal j that satisfies the criteria of being greater than all neighbors. Hence, I'll apply this till it reaches a value or till it reaches a point where it is not greater than, it becomes equal to any one of its neighbors. And the first time it will become equal to any one of its neighbors will be the maximum of them. And that's it for the second question. Okay, so we are here with the third question, update queries. Now, uh, the question statement says that I'm given a string of length n, as well as an array of indices of length m, and a string c of length m, right, which consists of alphabets, basically lower Latin letters, A, B, C, D, small case alphabets. And in order to perform the update operations, I have to just do s of ind I is equals to ci. What am I given? I'm given a string s1 till sn. I am given its n. Then I am given, let's say, uh, I1, I2 till IM. Its M is given, and I am given characters C1, C2 till CM of length M. This is also basically a string. And in the jth operation, what do I have to do? I have to say that S, whatever at the I jth index was, that is I1, I2 till ij. In the second operation, I'll choose I2. In the jth operation, I take ij. I'll change it to cj. Right. This is what we're doing in one operation. Now, of course, we can change the order of indices in the array and the order of letters in the string, and you can get different results. I have to get the lexicographically smallest string that can be obtained. Now, you might as well know what lexicographically smallest is. Just a little demonstration here. If I have two words ABC, and let's say ABD. There are two strings. The first point at which they differ, A and A are same, but the second letter is different. Now, the first place where they differ, the one which is smaller is lexicographically smaller. Now, this is same at A and B, it is same, but the first place where it differs, this ABC is less than ABD. Right, and this is the only definition we need to take care of. So I need to get the lexicographically minimal, which means that if I have this string, right, and I have, let's say, I have A's and B's to fill it with, I'll make sure, this is the greed over here, I'll make sure to get as many A's ahead as possible and as many B's later as possible. Or rather, I'll put as many A's as possible and that too ahead, and B's as minimal as possible and that too later. So I'll put A as maximum as possible and first, and I'll put B's minimal as possible later to make it lexicographically minimal. Right. So what do we have to do in this question? We say that, hey, I have string s1, s2 till sn. I have to modify this string according to this set of indices, right? And I have to modify it with and replace it with the character c1, c2 till cn. There are two key observations here. These are essentially observations. Firstly, if I have, let's say, if I have in this index, if I have 2, 2, 2, 2, and I have A, B, C, D. After all of these operations, essentially S of 2 will become D, whatever is the last operation, right? So what do we get out of this observation? That only distinct indices matter. Why distinct indices matter? Because whatever is assigned to its index previously will sort of be suppressed, you know? It's like I have A, I have B stacked on top, I have C stacked on top, I have D stacked on top. But this is the final letter that I see, right? So I don't care what this was, I just care what was assigned to it finally. That means if its occurrence is more than once, I don't care about how many times it has occurred. I just need to know whether it has occurred or not, whether it will be updated or not. That's the first observation. And the second observation is for lexicographically minimal, I have to put the smallest first. Smallest as many possible first. And that's it. Now the question becomes how to implement this. Well, the only two things that I have to do is I have to store the distinct set of indices and I'll have to get the minimal characters possible, as many A's possible as early as possible. I'll not keep my A's at the end. I'll keep my A's at the first. Right. So the implementation of this question comes down to this. Sorry. Yeah, this is correct. This is my implementation where, yeah, I'm recording. This is my implementation where I've taken the two values n and m. I've taken the string s. I have stored a set of indices in. Of course, a set stores unique values, and I know and I need only unique indices. But this set also does one more thing, that stores indexes in an increasing order. And why is that important? Because I need the lower indices to have smallest characters, as many smallest characters as possible. I want my A, A to be here and B, B to be here. Right. I don't want my A, B, B, A or something like this. This is not required. This is bad. A, B, B. This is better, right? I want the minimal characters first. And so what I simply do is I take the string, I store the indices in increasing order. I take the characters, character input, and I sort the characters. Right? I sort the characters, and then whatever indices that I get, I substitute that strings at that particular index at the very minimal of it. The first character of the vector will be the minimal one, and there cannot be anything lesser than that. When it's assigned to some string, then the next to it will be the minimal one. And hence, whatever the minimal number of indices that I have, unique, distinct indices that I have, I'll assign the smallest characters possible. These are the only two observations. I just need the distinct ones and I need the sorted characters, as many as early as possible. And that's pretty much about it for the third question. This was the implementation.
Hello friends, this is problem B from courses down line 50. You can pause and read the problem. So the problem states that you are given a string s, and there are n minus 2 operations you can do. The string s is of length n. So what you can do is that there are two operations, multiplication and plus. You can insert these in between the string. For example, instead our string is 1052. So here n is 4. So you can insert two characters. Either you can insert two characters, which would be either uh, multiplication or addition. For example, you can do this 10 plus 5 2, or any other possible addition such as 1 plus 0 5 plus here 0 5 get converted to 5. So after doing this n minus 2 process, we have to calculate what is the minimum value that you can. For example, in this case, you would get 1 plus 5 plus 2, which is 8. In this case, we got 10 plus 10, which is 20. So, there are few observations that you can make. Suppose that given length n is 5, 0, 0, 1. So you can see there are n minus 2 operations. So in all cases, there will be one block which is of length, and all the other blocks which would be of length 1. What I mean to say is that each time you insert any one of these plus and multiplication, there would be a, a number which would be of length 2, and all the remaining one would be of length 1, which means each number would be 1 and 1 digit remaining. So in order to minimize, what we can do, uh, we could just insert plus in between, because if the number is say 1 3 4, then why we would insert multiplication. This would just, suppose this 1 2 is of 1 2 is one digit, I mean 1 12 3 into 4. Multiplication would just increase the number, so it would be better if we insert addition between them. But there is a case, suppose that uh, we have 1 2 3. So here we can insert one digit. Suppose that this is a two digit number and this is the one digit number, and instead of addition, in this case what we can do is could simply multiply 1 and 23. So if there is 1, we would take multiplication, and for remaining ones we would take uh, for remaining digits we would take plus operation. And also if there is 0 somewhere, suppose we can form 1 0, the number is 1023. So we can separate out 0, and this could be 1 into 0. So in this case, multiplication is also preferred if there is 0. So for ones and 0, we would perform multiplication operation, and for the remaining ones we would do addition. So how to solve it? Suppose uh, the given number n is 1, 2, 3, 4, 5. There are 6 digits, so you can 4 operations in it. So what I will do is that uh, I will traverse in this string, and I will select a 2-digit number each time. So first I will select 1, 2, and all the remaining ones, that is 3, 1, 4, 5, they would be a 1-digit number. So I will perform addition on them, and we would take care of the cases when there is 1 or 0. So each time, first 1, 2 would be a 2-digit number, then 2, 3 would be a 1-digit number, then 3, 1 would be a 2-digit number, so on, and the remaining would be 1-digit number. So in order to get the sum of the 1-digit number, we can create a vector. Let's call it digits, and it would be of length 10. It would be a frequency type of vector. We would simply store the frequency of all the digits in this. That means it would be a frequency vector. Just store the frequency of each number. So if a 2-digit number, say 1, 2, is decided, so the remaining number, for the remaining numbers, what we will do is that we will run a loop from 2 to 9, and uh, we would what would be the value of the what would be the value after performing n minus 2 operation. So it would be, suppose 1, 2, in this case it's decided, so the remaining ones, for them I would traverse the from 2 to 9, and I will simply multiply I in digits of I. So this way I would get the value of all the 1-digit number that is present, and the 2-digit number would be calculated separately. So consider I am at index I, so I, S at I, and S at I plus 1. So it suppose S at I is A, sorry, suppose S at I is, this is A, this is B, then the 2-digit number would be uh, A plus 10 in B, and this would get us uh, the value of the 1-digit number traversing from 9. So things should be more clear if you see the code. So here is my code for it. So I have taken the input of string. I have created a frequency vector. Its name is digits, and it is from 0 to 9. It will store the frequency of digits. This is where I have stored the frequency of digits. Now I have initialized a minimum value in 64 max. Now suppose that our number was 10369. So suppose that uh, we will traverse from 0 to n minus 1 in order to get the two-digit number formed in each case. That is, uh, first would be s at I minus 0, second would be s at I plus 1 minus 0, and its value would be n times a plus. And since we have, in this case, now what we are doing here is, since we have consumed a and b, so we will decrease them in the frequency vector. That is, digits of a is decreased and digit present digit of b is decreased. There is a variable p. I will explain why I have taken p to 0. So suppose if, and there is also one case, uh, this case correspond to if a digit number 0 is present. Suppose uh, this, what this tells is that there is a 0 present in the array, I mean the string. So we could simply perform multiplication operation among all that is present, and what we will get is the value 0. So in this case, the minimum value would be 0, and this is the minimum that we could get. And then we would move further. So here what I'm doing, suppose that this is for the other cases that we have selected a two-digit number, then we need the sum of the digits, which are which is of length 1. So this is, I will traverse the loop from 2 to 9, and then this would store the sum of the digits which are of size 1. And I have in the value, in the variable val, I have stored the value of the two-digit number. So if, but there is a case, suppose uh, that it is, suppose that why we selected this as our two-digit number. So in this case, instead of adding them in uh, the digits, so 1 plus c plus 9, that would be stored in our variable p. So instead of adding this two-digit number, that is val in our case, to, instead of doing val plus p, we would simply multiply val into p. And so here is, if val equals to p and p is not equal to 0. Suppose that the given number was of length, was of only two digit only. So in this case, the value of p would be 0, as there is no other one digit number. So for this purpose, we would, uh, if this is not the case, the value equals to 1, and the we are able to get some numbers, some one digit number, that is p is not equal to 0 from here, then we will take mini equals to minimum of mini comma p. And what p store is that the sum of the one digit number. Or if the value of val is not equal to 1, it's something else. Suppose it was 12. Suppose that You can take an example. Suppose it is 1324, and this is our two-digit number. So, and 2 plus 4, that would be stored in the variable p. This is stored in y. So, if it's the other case that value is not equal to 1 and p is not equal to 0, it's the other case. In this, we will take the minimum of mini and val plus p, and after this, once we get the minimum, once we change the mini accordingly, now we will undo the operation that we did here. That is, for the next cases, we would increase the frequency of the digits. Suppose 13 was consumed at one process. For the next iteration, in the digits, which is our frequency array, I will again set it to our original value. What was the original case? This would make it original digits, whatever was stored in the stored originally in our digits vector. So while traversing all possible two-digit number and the remaining one-digit number, we would take the minimum and would simply print it. And the other cases, which is which are the cases of 0 and 1, is I have also discussed. Case of 0 and for the case of 1 and for remaining. So thank you.
So we given this is the question. We given an integer array okay, and integer k. You need to make it beautiful, and you can shuffle the array as you like before doing anything. Only before doing anything, right? So you have to first shuffle, then you do. For one operation, you can do the following: choose an index I and make ai is equal to a plus k. The array bi is beautiful if it's basically Palindrome notation, right? Bi is equal to b of n minus I plus 1 for all indexes. Find the minimum number of operations needed to make the algorithm or report that it is impossible. So let's think of this. We have to make the array palindrome basically, and we can write the operation a is equal to a plus k for any index. And we are also the case fixed. We're given them. Right. So think of the first example to this point. I think this question can think normally how can we let's take some examples. Let's say we have um, you know every number a1, a2, a3, a4 to an. Any number you can represent in form of like division, right? We have k. Let's see what happens if we divide each number with k. How can we represent it? Q1, some question we don't know the exact question there. Okay. So, we don't know the exact question there. Q1 times something k plus r1, right? All numbers will be represented in this way only. Let's say this sum qn plus qn k plus rn. All numbers you can represent in this form. Now you're adding only k to each integer in the operation, right? In the operation, you're only adding k. So every number you can represent as way. And if you apply an operation on any number, like let's say you apply an operation on this number, right? If you maybe you do this, then if you think about this, the remainder does not change. And these get mixed. Q1 plus 1 it becomes. So the remainder still remains the same. So basically, you can never change the type of the number. And I'm defining the type of a number by the remainder it gives. Let's say if R1 and Rn are equal, so no matter how many operations you apply on these both two numbers, they will be in the same group. And I'm defining groups by what is the remainder. Right? So now you have to think of this. Two people in the same group, meaning having the same remainder with k. You can convert one to other by applying operations. How? So basically, Q1, let's say there are two numbers, Q1k, QIK plus RI, and then there's another number who has the, let's say QJK, but it has the same remainder, RI. I'm not adding them, let's say two numbers are there. Then you can subtract these two, RI will cancel, and QJ minus QI into K we have to make using the difference, right? We have to make this using K because we are given that we'll add K each time. This is the difference we have to make using K. We do, then this exactly divides it. That means we can exactly make it Qj minus Qa operations, right? So the basic point is any number can be represented like in terms of the division algorithm when you divide it by K. And people having same remainders are in the same group and they all can be converted to each other, right? So if someone, if let's say A1 can convert it to, okay, can be converted to A3, then we can put A1 and A3 at the end like this, and A1 and A3, then you can make sure that these two will be equal, and the operations you will just count this value. That's as simple as that. But now there are some other cases, right? So each group should have an even number of elements because you want to make first element equal to last element. It's like a palindromic thing, right? One, two, three, four, like this. So each group should have a even number of elements. If it has an odd number of elements, that means one element will be left. If odd number of elements in a group, elements, then we have to think the one guy which will be left, we'll have to put in the middle of the array. If it's odd size array, this kind of thing, then you'll put him in the middle because he cannot be paired with anyone. Let's say the number of elements are three in a single group. By single group means they all give the same remainder. They all give the same remainder, same remainder they give. So one you can put here, one you can put here, but the last one where will you put because you cannot match it with this one because these guys will be of different groups. So if you put it here, then you can. If you put it here, then this person cannot become this because they're in the different groups. People in different groups cannot match because the remainder will never change. Right? The remainder will not change, and the numbers will remain always different, even if you add k, no matter how many times. So the basic point is if some group meaning same remainder people have odd number of people, then one of them should go in the middle of the array because that is how you can satisfy the condition of palindrome. Otherwise, it won't work. So if there are groups with if there let's say two groups with odd number of elements, then it's obviously not possible because you have to put two elements in the middle, right? Two elements, how can you put in the middle? So, okay, so this is the basic idea. Now let's think of this: how to calculate the number of operations, right? So we'll think of that one. Now we'll think how to count the number of equations. Now, what I'm saying is we'll segregate everyone depending on what is the remainder they'll get. Then I'll put them in the group with the people having the same remainder with me. So let's say we have a group remainder which gives R1. R1 remainder it gives with K. This group we have. So let's say we all the elements are in here. Now these all elements is in the same group, so one can be connected to other. Let's say the size of the group is even for now, because we wanna make sure we need to convert every element to some other element. Now we'll sort these elements because that will make sure that we'll get the least cost. And what we'll try to do. Let's say the number of elements are four. If we sort these elements, let's say we'll be able to convert A1 to A4 because it's better to convert A1 to A2 or A2 to A1. obviously A1 to A2 because we are adding K, right? So it's better to ground A1 to A2 because A1 and A2 are closer to each other than A1 to A3 or A1 to A4 because I've sorted it. And these all are in the same key. So what will be the cost? The cost will be A2 by A2 minus A1 by K plus A4 minus A3 by K. This will be the total cost for this group. We just need to get some pairs which will be equal. Now you can put A1 and A2 at the end of the array, then A3, then A4. Because these pairs are equal, right? So this will make a palindromic like situation like you. So these will be equal. There will be no issue there. So the basic point here is how many number of operations? The difference divided by k. And this difference will always be divided by k because they all have the same remainder. So remainder part will cancel out and the question part will be left. And this will divide it directly. This is in the case of even, right? This is in the case of even. Now we have to think about some a different case. When let's say the number of elements are more, then it's a bit tricky situation because we need to skip one element, right? That element can be anyone. Now let's say we have seven elements. A1, A2, A4, A5, A6, A7. Now it's this. Now because we have to skip one element, right? Because we wanna make six pairs here. Like we'll make six pairs here in such a way. Let's say this when we put them, like this will match, this will match, and one element will be left. We need to remove that element in such a way that the cost is minimal, right? That the cost minimum because we want to make sure the minimum cost we do. So let's say we remove a particular element A3. Then if you think about this, what is the prefix cost and suffix cost here? Now here A1 and A2 will be matched. Then A4 and A5 will be matched because I've sorted it already. This is sorted. And this is a group with same remainder group. Now let's say if I'm removing A3, I'm gonna check by removing each element what is the cost that we can get. So let's think about if A1, if you remove A3, what will be the cost? The cost will be difference of A2 minus A1 by K plus similarly A4, A5 and A6, A7. So A7 minus A6 plus K, A5 minus A4 by K. So if we remove an odd number element, then the cost will be let's say this you can keep in suffix, right? This cost you can keep in suffix. A7 minus A6 plus A5 minus A4. This you can keep in a suffix type. Take last two elements, then the elements just before them, third last and fourth last element, fifth last, sixth last element. So if you remove an odd number element, it's odd, right? Odd index of the element, to try and remove it. Then we'll use, so let's say we remove an odd number of element, right? So this cost you can keep it from prefix cost. You take first element, second element, then third element, fourth element, then fifth element, sixth element. This cost you can keep in prefix array, and then you can keep this cost in suffix array. So prefix, let's say we remove an element I, and prefix of I minus one plus suffix of I minus I plus one. That will be the cost, right? And this is for odd and odd index. In an odd size array, right? In an odd group, let's say there are odd number of elements, right? And in A7. Now let's say we remove a even element. Try and remove the even element, then what happens? Then we have to do this again. Let's remove this one, and let's say we'll remove a odd element. Now let's say we remove A4, which is even number element. If we remove this element, what will be the cost? So you can similarly get the cost like the same way like we did earlier. Now we have to take this guy in the front, A5 and A3 we have to take. Get the cost from these two. Then go prefix of I minus 2. Because this will again have the cost from starting to end. And suffix of I plus 2. Because this will again have the cost from end to this particular index, right? Because this index is even. So the cost of A5 minus A3 plus the prefix cost plus the suffix cost, that will be the cost. So this is quite easy. If I is even, this is all going on when this is the odd group. The odd group meaning the odd, it has the odd number of elements. This if AI is even, then you can take AI plus one minus AI minus one by k plus now suffix of I plus two plus prefix 5 minus 2. So this is the cost in if you remove an even number element. So basically we have to implement this simply, and this is the whole solution. You see the solution in the solve. So rather than storing the numbers themselves, I'm storing AI by k. If I store AI by k, I just need to take the difference of the numbers. So AI by k, I just need to take the difference of the number to find the number of completions. Say you can not store this, you can store the number itself, that won't change anything. So I'm using map int vector int. So for each remainder, I'm keeping vectors like the group of that uh, remainder. IT model okay, push back IT by k because I'll take the difference and that will be the number of operation that we have to apply. Then we'll sort. Now we'll go to each group. The answer we have initialized. We count I'm taking how many groups are with odd number of elements. If there is more than one group with odd number of elements, then it is not possible, obviously, right? So let's say we take down the vector, then I sorted the vector. Then let's think of this. There are two cases. If it's an even case, then we'll just take the difference of all the elements, right? Basically, if it's an even group, that means the difference of all the elements. So if the size of the array is even, then we are taking like the difference of the consecutive elements. That will be the cost. I'm just taking the difference because I've already divided by k, right? You can not divide by k and you can do vi minus 1 by k. That will also work. That's the same thing. I just wrote it like this because I don't want to divide by k again and again. Then I'm making prefix array and suffix array. Prefix array, I'm taking a difference of consecutive elements, right? That is what I told how to do this. Take difference of consecutive elements from starting and from ending and just skip by two. So that is you can do this like this. And now if you think about this now we are going to each element and we'll try to remove it. In that case, if we were having one base indexing, so when we were having odd element, then we were taking prefix and suffix only. And even element, then we were taking the difference of the next and previous element also. So it's just the opposite here because it's a zero base indexing. If it's even index, we'll take a prefix of I minus 1 and suffix of I plus 1. That will suffice. You can go through this again. It's very simple. And in the case of if I is odd, you have to take the difference of the next element and the previous element. And C plus, you have to take the prefix I minus 2 and suffix of I plus 2, like in the even case that we had here. That will happen in the odd case because this was odd with 1 minus maximum and this is 0 base maximum. We have to take the minimum of all costs. Why? Because we want to make sure the cost is minimum. And the point here is removing a particular element will give you the minimum cost. So we are trying to remove each element and check the cost. So answer plus cost, this is the total cost, right? And you can check this. This is quite simple. For even size, we're taking the difference of consecutive and elements simply, and obviously skipping the pair again. Then on odd case, we have to remove a single element, right? For that, we're doing prefix sums and suffix sums. You can go through this explanation again if you have it, any issues, or you can ask in the comments. And if the count of odd number of elements is greater than 1, then it's obviously minus 1 for odd number of group elements, right? If the odd group elements, if they are more than 1, then the answer is obviously minus 1. Otherwise, you can just output the answer. So thank you for watching. This is the problem F of the deep sea night storm. So we'll be discussing this. So given a connected undirected graph, the vertices of which are numbered from 1 to n, it asks us to minimize the number of pair of vertices UV such that V is greater than U. Okay. Between there is a path in the graph. To achieve this, you can remove exactly one edge from the graph. So we have to disconnect as many vertices as possible by removing a single edge in the graph. Okay. Find the smallest number of pair of vertices. So we have to remove exactly one edge, and we have to make sure that number of vertices which get disconnected are as much as possible, right? Okay. So if we look at the constraints here, that m is greater than or equal to n. So initially the graph is always connected because there is no multiple edges or there are no subgroups or anything. So if there are n minus one edges exactly, then the graph is connected, simply connected, right? Like a tree. And if there are more edges, then it's connected and there are cycles. So the main point here is that the graph initially is always connected. We need to remove a single edge which splits it into multiple components, or it will split it into two components, and each component should have as many vertices as possible, such that after removing the edge, we'll reduce the number of pair of vertices which are reachable from each other. Right. So, let's think of this. It's actually quite simple if you know a particular algorithm. We'll come to it in a minute. Let's say this is the graph and something like 4, 5. See, we'll always remove an edge which splits the graph into two components, right? If we remove this edge, there is no point, everyone is still connected. If we remove this edge, no point. If we remove this edge, it will be disconnected into two parts, right? This part and this part. So if it will be disconnected, then the number of vertices in this part into the number of vertices in this part, 3 cross 3, will be the amount of pairs which cannot be generated now. Like if you think about this, now you cannot reach from 3 to 4. So 3 to 4, 3 to 4, 3 to 5, 3 to 6. So each pair with each guy from left side with is mapped with each guy of right side. That means 3 cross 3. The number of nodes here is, let's say, k. Here is j. Then k into j amount of vertices. K into j amount of pairs of vertices will become unreachable from each other now. Right. So we need to remove an edge which breaks the graph into two different components, and we want to maximize this multiplication. The multiplication of number of nodes on the left side and then multiplication of the number of nodes on the right side. Let's focus on this. How can we determine that if we remove this edge, then the graph will be split into two different components? That's quite an easy algorithm, but you should know a bit of graph theory before this. So if you don't know about the Tarjan's algorithm, it will be a bit difficult. So I recommend you go through Tarjan's algorithm. Then, if you know that it is used to find the bridges in a graph, right? And bridge is defined as edge, edge on removal disconnects the graph. Okay, breaks the graph or disconnects the graph. So we can find edges which disconnect the graph into two different parts by this Tarjan's algorithm directly. Uh, and I'm gonna give a very brief idea of it. I cannot explain a full algorithm because it will take a good amount of time. We don't have that much, like 20 minutes it will take at least to get a full clear idea. But I can give an idea, like a simple idea. We just have to do a DFS. Let's say a simple DFS in which every node will have two times. Let's say this node is there, 3 and 4, 5. Let's say we start the DFS from here, and we will give each node a time. What time? We'll give it a time when we start there. Like when we are starting from this second position. So initially the time is 1. Let's say initially the time is 0. There will be two times. 0. There will be two times. One is the time of insertion, or other time will be the minimum time to reach this place. Min time to reach this place. Right. So let's think of this. When I come to now I'll do DFS for me. I'll come to this there. The time of insertion here will be 1, and the minimum time we it's still 1 because we have not taken from minimum, right? Uh, and now the DFS call for 5, 3 is done. Now it will go below to 4, or it might go to 5. We will see to it. Let's say it goes to 4 currently. Then the minimum time of insertion of 4 will be 2, and here also the insertion time and the minimum time is 2. Both are 2. Now when we come back after visiting a node, now we'll be coming back by the recursive manner in DFS. After 4, we'll come back to 3. Now we'll check that the insertion time of this node, right? The insertion time of this node must be insertion time of this node, but the parent node where we are standing right now, like at 3 we are standing. This should be like greater than or equal to minimum time of the neighbor we are coming from. Minimum time of neighbor. If this is the case, what does this mean? Minimum time of neighbor means at what minimum time I can reach that neighbor. 4 I can reach at time 2, and the minimum time required to reach this particular parent is 1. So 1 is greater than equal to 2. That condition does not hit here. If this condition is hit, then the point is that this edge cannot be a bridge. Why? Because if we can reach by a neighbor through a time which is lesser than equal to the time of this particular node, then we'll not go to then we can remove this edge and we can still reach it back to the particular parent. But if this time is other way around, let's say if the time of insertion is is less than the minimum time of neighbor, what does this mean? This means that we're at the parent node 3, let's say, and then this 4. Then the time of insertion of this node and the minimum time to reach this node, look at the condition here that we have to insert this guy first, then we'll come here. Now, if insertion of this guy takes place before the minimum time to reach this guy, then we can never reach him back if we remove this edge. Then this edge is a bridge in a graph. So the basic idea is this: whenever time of insertion of parent is less than the minimum time required to reach the neighbor, then it's a bridge, because if we remove that edge, we can never reach that neighbor without reaching that particular parent. And we are removing the edge between the parent and the neighbor, so we will not be able to reach this 4. If we won't be able to reach this 4, that means it's divided into different components. So we got a basic idea of how this algorithm works, but you should actually go, and if you don't know about it, you should go and check it out, because then it will be much easier. So we'll now come to the simple implementation of Target's algorithm. So this is the course. So we're just taking the input and nothing else. And initially, n into n minus 1 by 2 will be the number of error vertices that are reachable from each other. Because the graph is already connected, at least n minus 1 edges are there, so everyone will be reachable from everyone. So n into n minus 1 by 2. N into n minus 1, if you do, then uv and vu both will be counted, but it is given that v greater than u, you should take in uv pairs. So you should do half of it. And then this is the time of insertion. This is the minimum time of insertion. And then I'm keeping bridges. You don't actually have to keep the bridges. I just kept it like it's in the algorithm. I just directly use it quickly. And the algorithm is quite simple. Whenever you visit a node, you mark it. Then you set the lowest time of it to a timer, and lowest time of node and the lowest time of as timer. Then you timer plus. Then you will go to all its neighbor. If it's not visited, you will visit it, and then you will check the condition which I was telling. Law of IT should be greater than, if it's greater than the 10 of node, that the minimum time to reach the neighbor is more than the time to reach this particular uh, parent, then it's a bridge. And what I'm doing is I'm returning a in type of function which will return the number of nodes in a particular component. Right. So when I'm coming back from this particular neighbor, I'm finding out how many people I visited there, how many people I visited, which gives us the number of different nodes in that graph. And then we have to remove the most number of UV pairs, right? So right side, let's say there are val number of nodes. Then left side, how many nodes will be there after removing this particular bridge? N minus L, because total nodes are ends and all are connected. So N minus L into L will be the number of pair of vertices which will not be reachable now. So we can take the max of all of that, and then we can subtract it from the total number of pairs. Total number of pairs initially were N into N minus 1 by 2. Then we can subtract the number of pairs of vertices which are not reachable from each other now. So this is the simple solution for this. Thank you.